This isn't a voltmeter, it's an Arduino UNO, but it can measure voltage like a real one. Let me show you how. Today, we're building a simple digital voltmeter using the Arduino UNO R3 and a voltage divider. It's a great beginner project that teaches how the analog to digital converter actually measures voltage. For this project, all you're going to need is a breadboard, a 0.1 microfarad capacitor, a 100 kiloohm resistor, a 20 kiloohm resistor, a Arduino UNO R3, 2 probes, some wires, and an I²C LCD screen.
Here's the circuit layout before we start wiring. The 2 resistors form a voltage divider that safely scales the input voltage down for the Arduino. The midpoint between them connects to the analog A0 pin. This is where the board reads the scaled voltage. The top resistor, R1, connects to the red probe input, and the bottom resistor, R2, connects to ground with the black probe. Together, they split the voltage by a ratio of 1 to 6, so 30 volts in becomes 5 volts at A0, safe for the UNO. That tiny 0.1 microfarad capacitor between A0 and ground filters out any electrical noise, keeping the reading rock steady. Now, let's put it together.
We'll need to start with the 5 volts pin into the plus side, the ground pin into the negative side, A0 into B13. Now we can go from D14 into ground. We can then take our 20k ohm resistor from E14 to E13. We can then take the 100 kilo ohm resistor from A13 all the way up to J1. That completes our voltage divider, which keeps only 5 volts going into the A0 pin. We can then take the capacitor from C13 into the ground side. We can then attach the LCD from going from A5 to C28. We can then go from A4 right above that. We then take power right above that one. And then ground right above it. We can then attach our LCD screen. We can then attach the plus probe to I1 and the negative side probe to the negative side of the breadboard. Once it's all wired together, it should look roughly like this. Now, we need to code it.
And here's our code. We start by including the wire and liquid I²C libraries. These handle communication with the display over the I²C bus. Most displays use 0x27, but if yours stays blank, try 0x3f instead. Here, we define the calibration values. VREF is the exact voltage of the Arduino's 5-volt rail. Measured with a real multimeter for accuracy, R1 and R2 are the 2 resistors forming the voltage divider that scales down the input. This function reads the analog pin and averages 16 samples. Each analog reading converts the value from 0 to 1023, representing the 0 to 5 volts. Averaging smooths noise, and the short delay lets the ADC settle for stable readings. Inside the loop, we call that function to read A0, then scale the measured voltage back up to the real input value using the divider ratio. Next, the LCD is updated. The first line shows the label and the second line prints the actual voltage value. The display automatically switches between millivolts and volts, keeping the numbers easy to read. Under 1 volt, it shows millivolts. Above that, it shows volts with the right number of decimals. Finally, a short delay controls the refresh rate, about 6 updates per second, fast enough for real-time feedback, but slow enough for steady readings. And that's it, a few lines of code that let the Arduino safely measure and display up to 24 volts DC. Next, we'll test it against a real multimeter and check how it reads.
Now let's test it against some known values. This is a 9-volt battery. According to our multimeter, it reads 9.5 volts. According to the Arduino voltmeter, we read about 9.7 volts. Let's try another. With this 9 volt, we read about 8.8 volts. Our Arduino reads roughly 9 volts. But to roll out any variations between the multimeter and voltmeter, here is a known value power supply. And I have it set to 12 volts. Connecting our multimeter, we see 12.3 volts. Changing the value, we can see that our multimeter adjusts in real time. However, it seems to be off by about plus or minus 0.2 to 0.1. This means that it's good for any application that doesn't require a precise amount of volts. But I guess if you had an application that needed super precise voltage, you wouldn't be using an Arduino UNO voltmeter. Now, let's see how high we can take our voltage. We can see that our Arduino UNO reads up to about 24 volts with no actual issue. I don't actually want to go any further than this, just in case there is actual risk. I would say that this voltmeter will accurately read up to about 24 volts, but I would not take it any higher than that. The applications for something like this is monitoring sensor outputs, battery levels, or supply rails on other projects. Just remember, it's DC voltage only, and to keep the input values below 30 volts. Thanks for joining today, everyone. That's how to build a pretty precise digital voltmeter with an Arduino UNO. Simple, accurate, and expandable. Subscribe for more practical Arduino tools and hands-on electronics builds. Thanks!